Good morning, everyone, and I'd like to thank for the opportunity to present my work and to be selected for this award. Basically, I'm going to talk about functional coatings. Before I start talking about the coatings themselves, I'm just going to make a brief introduction about me. So I come from the lovely city of Aveiro, located in the center of Portugal. Currently, I'm assistant professor at the University of Aveiro, and I've been working for 10 years in the development of nanomaterials for coating applications. I'm also founder and a board member of a startup company in the same field, in field of coating developments. And my background is in chemistry and physical chemistry applied to material science. So now about really the presentation. I'm going first to talk a bit about coating, functional coatings. I'm going to describe shortly some of the materials degradation mechanisms that I've been focusing in my research, the approach that we use to develop smart additives, and the challenges associated with it, and how from these challenges we generate new materials, new applications, and we use new tools. In the end of the presentation, I'm also going to make just a short overview about the impact of communication in my career. So coating, basically, it's a layer that covers a substrate and confers usually decorative and a barrier or a protective effect. If we have additional functionalities like corrosion inhibitors that are released from the coating, which confer active protection, or anti-fouling compounds that act against fouling, we call these kind of coatings functional coatings. If they have, in a way, capacity or capability to respond to triggers from the external environment, we call these coatings smart coatings. So in my research, we have been focusing mostly on corrosion. So my group is devoted to corrosion studies. And basically in corrosion, what we have is the degradation of metal due to its interaction with the environment. So we have the metal, which is oxidized, and the electrons from that oxidation reaction is basically used in the reduction of species coming from the environment like oxygen and water. The result of this is basically the consumption of the substrate, the metallic part, which is used as a structural component. And as a result, we have a degradation of equipments or degradation of structures. So the impact of corrosion in terms of economic factors is estimated between 2 and 4% of the GDP of most industrialized countries in the world. In addition to that, we can also have other impacts not measured by numbers like accidents and other sorts of problems. On the other hand, when we refer to biofouling, we have settlement or colonization of organisms on the surface. And what basically we have is that we have an increase in the roughness of these surfaces. And if we, for instance, think about a ship and the ship is traveling, the drag increases. So basically we can have problems associated, such as the increasing fuel consumption up to 40%. With other impacts like increasing greenhouse gas emissions and so on. So these are things that we want to avoid with our developments. So the approach typically used to protect a substrate in these applications, it's a multi-layer coating system. So there is application of different layers, and these layers have different functions. Some are used to promote adhesion, others are used to actually have corrosion inhibition properties, others to have the decorative and barrier effect. What we try to do in our research actually is to, what we see here as these yellow spheres, basically to develop micro and nano containers. So materials with the ability to release in a controlled way active species for the target functionality. And when we say controlled release, is designing the materials in a way that they respond to chemical or physical triggers associated with coating degradation or corrosion or fouling processes. So how we do this, or how we try to do this? First, of course, we need to have understanding of the process going on. if we are talking about corrosion, the reactions occurring at the interface, understanding the differences between different metal alloys and the conditions in which corrosion can occur. So we have to start by the screening of the active species for the target functionality. In addition to that, then we move to the immobilization of these active species. Why we want to immobilize? Because quite often they tend to react with the coating formulation, so they lose the activity, and at the same time we also want to impart, let's say, the stimuli responsive ability to the coating. So we try to match the physical chemical properties of the active species with the type of container that we want to use, and then use the container with that active species in the coating. The next step is, of course, the evaluation. We use different techniques, including electrochemical ones, as we have here in the examples, like electrochemical impedance or localized electrochemical techniques. And the idea is to see in the first stage if the materials, modified materials, are working or not. And of course, generally, we need to optimize the material. This can involve, for instance, the surface modification of the containers to change the triggering conditions, or co-immobilization of other active compounds. But in fact, this is not so straightforward. There are several challenges associated with trying to modify coating for target functionality. First of all, the way the compound should act. If it's for active protection, it needs, for instance, to be released and needs to be transported into the metal interface and work on interface. If we are talking about corrosion detection, for instance, it needs to signal a change, for instance, presence of water, or change in pH, or presence of oxidized species, or the anti-fouling, like the release of the compound to the coating solution interface. We also have to take into account that the release profiles of the containers that we develop may be different, and is actually different when we are talking in what happens inside the coating. And we also have to take into account conditions that these coatings are subjected to under service life, like weathering conditions that can lead to degradation of the molecules that we used. And at the same time, and one of the probably biggest challenge is to keep the coating properties intact, which means that if we are going to add the particle or the capsule, the coating properties needs to be kept. This needs to be done basically in a co-development with other partners, usually with industry, because they know very well the formulations that they are developing. In addition to that, we also have to take into account the environmental impact of these materials. So if we are developing, for instance, a particle with a biocide that is to be used in anti-fouling coating, we have to take into account that this will be in contact with aquatic systems. So we have to also evaluate if we are increasing or decreasing the environmental impact when we are trying to do these smart additives. Last but not least, one of the big challenges also is when we are preparing these materials in a lab scale, and then there is a need for prototyping. So you have to pass from gram to kilogram scale, and so you may also have challenges in the production of these materials. Regarding to this last point, there was, in beginning of 2009, 2010, the need, we identified some promising nanocontainers for corrosion protection, but there was a need, we couldn't find an industrial partner to produce these materials for coating developments. So we decided to create a company to do this business, let's say, so to basically upscaling the most promising technologies that we were developing in the lab at the University of Aveiro. And this is actually the photograph you see here is actually the first industrial, let's say, unit from the company, which is able to upscale the synthesis of one of the materials we are talking about from, let's say, 10 grams per batch to 50 kilograms in dry content. So this was a very important boost, let's say, to help to make the approximation between the technology developed in the lab and industry. The company is still is actually thriving. It has been receiving several prizes, including the Seal of Excellence from the European Commission for the technologies developed. In addition to this, one may wonder why, as academic partners, we are interested in developing strong bonds with the industry, why we don't focus only on, let's say, on the scientific aspects of the developing of the systems. Actually, it's very important, I think, from my understanding, interaction, a very close interaction with the industry. And one of the examples I have is here. So basically, we were developing particles to add coatings, organic coatings, but we found out that there was also a need to develop, let's say, surface treatments with the same properties. And actually, we focused some of our recent research, and we were able to develop conversion films with controlled releasability based like on the nano container approach. And we can just basically see here that the application of a development of the conversion film with corrosion inhibitor leads to a significant decrease in corrosion. And this is a pretreatment that has been also co-developed in projects with Airbus. Another thing is that sometimes we may get ideas to generate new materials. Specifically in this case, we were challenged by industrial partners to see if we could somehow, in addition to impart or enhanced corrosion protection, if we could somehow add a functionality that would signal the starting of corrosion, because it would allow a maintenance operation going on earlier, so the costs associated with that maintenance operation could decrease and be more effective. And actually, we develop also additives that could actually signal the occurrence of corrosion. We see here one example, which is using additives with hexacyanophorate, and hexacyanophorate reacting with oxidized iron, giving the Prussian blue. Other situations here using pH indicators, so we can see here that the encapsulated phenolphthalein can actually change color when we have corrosion, whereas when we have the phenolphthalein just added to the coating doesn't work, it's deactivated. So in addition to these, we are also using these, let's say, ideas to generate and open new ways or fields or applications, including the development of coatings for biomedical applications, for instance, in magnesium alloys used as bioabsorbable implants, and also as anti-corrosion additives for concrete. One of the latest points or recent points that we have also related to our research is that we have been engaging in collaboration with other research groups, and one of them in theoretical chemistry, we have been using different tools like density functional theory, molecular dynamics, basically to understand how the inhibitors interact with the surface, also to understand how the release of the compound is actually or can actually occur. And also we are currently using machine learning basically to help us to find inhibitors in a more efficient way. Being this award for communication, I would just like to point out some aspects. So as I've just mentioned, some of the challenges associated with coating development are overcome if we combine the efforts and the knowledge of different groups and different sectors, namely industry. Just more than 1/3 of my publications have been done and published with people from other areas, namely biology, microbiology, ecotoxicity, but also with industrial partners. We have also 5 patent applications, 4 of which in collaboration with an industry and the startup company that I just referred. In addition to the communication that we do as academic individuals, including the peer review conferences and theses, we are also involved in presenting our projects in radio programs and also in the social networks to target especially younger generations. We are also involved in the organization of several events, including conferences. One which is particularly important for me was this international summer school. So I'm one of the founders of this international summer school, targeting specifically PhD students and young postdocs that want to develop knowledge and expertise in the field of responsive coatings and get knowledge on how to use appropriately techniques for characterization of these materials. Last but not least, of course, we have to talk about the situation that we live today. And this last semester, let's say, as a professor, was also very, let's say, hard to manage. And I suppose that for everyone in the community was also hard to manage. And from my experience, it came across that, of course, we have opportunities to use better the digital platforms Here I have just a snapshot of myself because the students could not go to the lab, so they could not have practical sessions. So I had to record demonstration experiments and providing them the data so that they could actually somehow write reports and understand what was going on. Also, it's very important that we are able to refine and improve our message because the way we interact is different. So we don't have the physical contact, the proximity of a room with an audience. So the message needs to also be somehow refined to deliver. And finally, last but not least, I don't like in Portuguese we have the expression social distance, but I think that means isolation. And actually, we have to take into account that we first, for communicate properly with our students, we have to have empathy and establish a common ground of communication to actually transfer the knowledge appropriately. So after this talk, I'd like to thank SPM and FEMS for the opportunity to present our work in our group and for the funding that we have for this research. And thank you for your attention.